GAUTENG Department of Education, grade 12, June examination 2022, mathematics paper 2. So this is a 3-hour paper out of 150. And yeah, we're basically going to go through the entire paper without leaving anything out. So the link to the PDF file is in the description. And then also the timestamps that will be able to like take you to any question in the paper are also in the description. But anyways, hi guys, Levi here from Bright Young Brains. Levi here from Bright Young Brains, as in Levy. Yeah, but anyways, let me just not waste time and get right into the paper. So question 1 here said, right, the box and whisker diagrams below show the mathematics results of class A and class B in the June examination. And then it says it is also given that class B has a median of 65%. So if class B has a median of 65%, what that means is, you see where this is, right? This is where Q2 is. Because remember, Q2 means median. And our median gives us an idea of like where half of the data is. So this is telling us that 50% of everyone got below 65, and then 50% of everyone got above 65. So in my own opinion, because the median of class B is higher than the median of class A, clearly class B definitely did better because half the people have above 65%. Here we have like 45%, which is, yeah, bad. But anyways, it says here, which class had the top learners? So here it's definitely B, like without a doubt. Reason being, half of the learners have more than 65. You see, half of the learners only have above 45. So yeah. And then it says here, determine which class had the greatest interquartile range. So interquartile range, you can actually just always work that out if you need to, because your interquartile range is always equal to Q3 minus Q1, of which in this case, they want us to get the interquartile range. Let's see, which class has the greater one? Okay, so we can work out for both. I mean, whichever way, you can clearly see that B is going to have the higher interquartile range, because this value here is like 75, this value here is like 30, and then the value here is like 55, the value here is like 35, you see. So if you compare the two, 35 and 55, the difference there is just a 20. From here to 75, clearly that's much higher. So without needing to worry too much about any calculation here, it's just a 1-mark question. So we can just give our answer as B. 1.3 says, what percentage of class A scored lower than 60%? So what percentage of class A scored lower than 60%? So let's see here. So this is where 60% is, right? So we have 60% over here. Now, what we know is this is where Q3 is, right? Q3 is over here. So Q3 is 55%. So what we know is 75% of the people have lower than 55%. But then they are asking us what percentage of class A has lower than 60%. So if we're going to work this one out, we have to think, strategically, because if you think of it nicely, the only thing that we know is the minimum percentage was 10. The maximum percentage is clearly 75. And yeah, kind of have to think about this one, because obviously since it's a 1-mark question, we don't want to overthink it. We obviously want to think of the what you may call the easiest or the most logical way to answer this question. But let me see again. What percentage of class A scored lower than 60%? Well, it's definitely, yeah, it's going to be more than 75% of the people, because Q3 is here. This is where 75% of the data would lie. Everything below 55% is 75% of the data. So at 60%, it's kind of difficult to judge, because, I mean, all we know is that 50% of everyone got more than 45%. So funny enough, between 45 and 75, right? What's the difference here? Between 45 to 75, that's a difference of about 30. So logically speaking, let's check what the middle of 45 and 75 is. Yeah, because this is actually quite interesting. Like, good Lord, dang it. So let's see. 45 plus 75 equal, divide this by 2. I just want to see what is in the middle there, because my suspicion is 60 is in the middle there. 45 plus 75 divided by 2, 60 is in the middle. Okay, which is perfect, because what this tells us is, you see, this is where 50% of the people are, and then this is where everyone ends. So in the middle there is 60, of which what's that technically speaking, what that is telling us is that 75% of our people have lower than 60%. You see, because between 45 and 75, 60 is in the middle. And then 45 is where 50% is. This is where 100% is. So in the middle, this is where 75% of the people would be. 75% of the learners. So this one is kind of strange, but that's what we are we are getting. I think the only thing that would be confusing about this question is the fact that Q1 is at 35, Q2 is at 45, and then Q3 is at 55. But so let's just put our answer here, B. No, 75%. 75% of the people scored lower than 60%. And then it says here, if all the learners in class A were given an extra 5%, what would happen to the standard deviation of the marks in class A? So remember, standard deviation gives you an idea of, on average, how far each piece of data is away from the mean. I'll repeat, standard deviation is a value that tells you, on average, how far is each piece of data away from the mean. So if every mark goes up by 5%, then logically speaking, the average also goes up by 5%, meaning that each mark, right, the distance between each mark and the average would still just remain the same. Because if each mark goes up by 5% and the average also goes up by 5%, then each mark, its distance from the mean is gonna stay exactly the same. Because if, let's say, the mean is here at 50 and the mark is here at 20, if this mark goes up to 25 and this mean goes up to 55, the distance here is still at 30. You see, before that it was also still at 30. So if the mean increases and the individual mark increases, there won't be any difference in the distance apart, of which standard deviation gives you an average of all those distances between each value and the mean. So if each number goes up by 5%, then your standard deviation won't change. So no change. Let's just say yes, standard deviation would not change. Fortunately, it's just a 1 mark question. And then for another mark, they say determine the semi-interquartile range of class B. So funny enough, when they say semi-interquartile range, remember interquartile range, right, is just Q3 minus Q1. That's the interquartile range. But the moment the word semi is introduced, remember semi means half. So here, the semi-interquartile range is just the interquartile range cut in half. It's just like a semicircle. Remember, a semicircle is half a circle. So our interquartile range for B, as we know, as we said here, it's just going to be 75 minus the 30. And then we have to divide that by 2, right? So it's going to be 75 minus 30. And then we're going to have here, what are we going to have here? 75 minus 30 over 2. This is going to give us 45 over 2, of which that's just going to give us 22.5. Perfect. Okay, so let's keep on moving forward. It says here, question 2, right? A group of 30 pupils was asked to complete an obstacle course in their grade 11 camp. Okay. And then it says the times in seconds taken by the pupils to complete the obstacle course are given in the table below. So this is saying people that took between 60, what did they say in seconds? Yeah, 60 seconds to 90 seconds. It was just 3 people. So clearly these ones finished the fastest, and then these finished the latest. So as you can see here, they're telling us between 90 and 20, there's 6, going on and on and on. So they want us to complete the cumulative frequency table. We should fill up this column, right, in this table. So we all know that what you need to do here is you're just going to be adding up the values one by one. So for example, for 3, you only still just have 3, so there's nothing to add. So you just have 3 there. If you add a 6, you can have a 9. You see, because 3 plus 6 is a 9. 9 plus 7 is going to give you 16. 16 plus 8 is going to give you 24. 24 plus 6 is going to give you 30. So what this is telling us is you have 30 people in total, because 3 of them got this much, and then 6, and then 7 of them, and then 8, and then 6. So all these added up is going to give us a 30. This is just giving us, bit by bit as we're adding up the people. So that's going to be 1 mark. For 4 marks here, they said draw a cumulative frequency curve for the above data on the grid provided. So the idea is between in the data, right, you see here it starts with 60 to 90. So 60 to 90 is between here. Now you always plot in the middle of these two numbers. So between 60 and 90, in the middle there is like I think it's about 75. Yeah, is it 75? Yes, because to get the middle of those two numbers, you're just going to add them up, and then you have to divide by 2. So let's just actually get the midpoints of each of our values there, because the midpoints of each of these numbers and this is what we're going to be plotting. So in the middle here, we have 75. Between 90 and 120, let's see, you're going to add them up, divide by 2. So that's like 105. And then 120 plus the 150 divide by 2, that's going to give you 135. And then between 150 and 180, let's see what that gives us. 150 plus 180 divided by 2, that's going to give us 165, you see. And then 180 plus 210 divided by 2, that's going to give us 195. Perfect. So with all this being said, right, what we know is this is how you're going to plot the value. 75 and 3 is the first thing you're going to plot. So 75 is like in the middle there. And then 3, you can see, yeah, that's going to be somewhere over there. And then let's see here, 105 and 9. 105, we see it's in the middle here. 9 is going to be just below the 10, right? So it's going to be like somewhere there. And then 135 and 16. 135 and 16 is just above the 15, so somewhere there. And then here 165 and 24. 165, where is 24 now? 24 is just going to be below 25, so somewhere over there. And then 195 and 30. So we have like 195. 30 is like right at the top there. So whenever you plot your frequency, your ogive, right, your frequency curve, you always want to make sure that as you draw your curve, right, you want to make it as smooth as possible, and try to always make sure that it goes down to 0, one or the other, because it's just supposed to give an idea of, like, how data somewhat would perform. So here, let me put this in another color, just to show that it's just for the vibes. So this is what our cumulative frequency curve would look like. Now for 2.3.1, it says you indicate on your graph where you would read off. Indicate on your graph where you would read off the number of people that took 135 seconds to complete the course. Use letter A. Okay, so 135 seconds, right? Where would that be? Well, that's kind of crazy, because we already know 135 would be somewhere here. So we trace it there. And then what we already know is, I mean, like, funny enough, we should, we already have a rough estimate there. So we should at least be around 16. So that's going to be somewhere over there, just above 15 there. So this is where we would read off those 135 people. So they say we should label it A. This, they said we should indicate on the graph where you would read off the value of T. Okay. If 60% of the pupils took less than T seconds to complete the obstacle course, use letter B. The value of T if 60% took less than a certain amount of seconds. So what we need to keep in mind here is we need to just go to where 60% of the people would be. So if you think of it nicely, there's a total of 30 people. 60% of 30, you can actually think of it nicely here. So let's see here, 60% of 30. Remember, off means times. So you'd have 100 down there, 30 over 1. 3 times 6, that's like 18, and then 0 and 0, that's like that. I don't even know why I'm doing this, with my head when I can just use a calculator. But yeah, so 60% of everyone is around person number 18. So what we know is 18 would be just below the 20. So somewhere over there is where 60% of the people would be. So you can just trace that to our ogive, and then there is where we would read off 60% of the people. So here you could trace it down to the bottom, but you don't have to, because yeah, we really kind of don't have to, but we can just for the vibes, because why not? Why not? And then here it says the 75th percentile. So the 75th percentile, right? You need to make use of, well, technically it's the same idea with the previous question, because the 75th percentile is going to be, roughly speaking, where 75% of the data is. So here you're going to need to work out 75% of 30, of which in the calculator, let's just see what that is. 75 shift percent of 30, that's going to give us 22.5. So this is approximately 23, because we're working with people, right? So 23 would fall just above, just below there. Somewhere over there is where 23 would be, right? So this here, you can just trace it to your graph, and then we can make a point over there. This is where C would be. Then you can just draw dotted lines going down as well. So yeah, those were like the easiest 3 marks, clearly. But anyways, the reason we chose 23 as an approximation here is because, remember, we're dealing with people, so you can't have like half a person, or can you? Anyways, let's do question 3. Question 3 says, consider the following set of 4 positive whole numbers in their frequency. Okay, so you have different scores here. Score number 1, score number 2, score number 3, and score number 5. No, score number 1, 2, 3, and 4, bruh. So people that got this score, it was 4 people. People that got this score, it was 3 people, and then 2 people, and then 2 people. So they said you determine the median score. So the median score is basically the score in the middle. But the thing is, the way you want to look at this is you have to focus on the frequency. So the frequency, you can see there's 4, right? Plus 3, that's going to give you 7. And then plus 2, that's going to give you 9. Plus 2, that's going to give you 11. So the median, if you think of 11, right? The median would be somewhere at 5.5. So what you know is 4 is here, right? So for you to get 5.5, you would be within this range of scores here, because when you add 4 after 4, when you add 1 more, you're already in these scores here, and then 0.5 of that, you're still in this score. So the median score is basically 2x. You see, we don't know what x is, but we don't need to know what x is. All we need to know is that the median score is going to be somewhere in the in the middle, somewhere in the middle, somewhere in the middle. So this is quite interesting. But before we even get on though, like let's say here, so here we said 18 people, right? Before we even get on, I just want to just verify that you indicate on the graph where you would read off. Well, we indicated on the graph where we would read off all these things here, but I think we can also just put down, the actual values. Let's see, for the blue one A, this was around 135. So meh. Yeah, we did say this is around 135, and there it was around 16. Yeah, that was around 16. Was it around 16? Yeah, it was. Yes, it was. Yes, it was. Well, we kind of finessed it, but this was around 16, bro. Come on now. And then here, this was around 18 people. Yes. And then down here, the 75th percentile, we read it off at 22.5. So this would be, yeah, somewhere between 150 and 180. Between 150 and 180, that's like 165, right? So let's just put the 165. The reason for doing this is just so that at least we have multiple data for those sets of questions, because the question is a bit vague also. So fortunately, we have read off whatever we can read off from our graph, and then wherever we were tracing our data to, we just put in those key pieces of information. So this is what, in seconds, right? And then this is people, 118 people, pupils, and then here this is 16 people also. That literally just came out of nowhere in my mind. But anyways, here we said that question 3.1, yes, we have put there the median score as 2x. Now, just thinking about it also, I'm not too quick to move on to the next question, because I'm thinking to myself, okay, fine, but then why would it be 2x though? Yeah, 2x seems to be the one, because as we said, consider the following set of 4 positive whole numbers and their frequency. So what you would need to visualize is for what you may call for x plus 3, right? You would have 4 of them. So meaning you'd have x plus 3, another x plus 3, another x plus 3, and then another x plus 3. And then you would have 2 of these, right? I mean, 3 of the 2 x's, 1, 2, and then 3 of them. And then you would then have 2 of the x minus 1. So you'd have 1 and then 2 of those. And then the 6's, you would have 2 also, you see. So then you would just have 2 6's like that. You would have a 6 here and a 6 there. And then before that, you would have 2x minus 1's. And then before that, you would have 2x, 3 of them. So you'd have 2x here, 2x there, and then 2x there. And then before that, you would have x plus 3, 4 of them. X plus 3, x plus 3, x plus 3. Because it says consider the following set of 4 positive whole numbers and their frequency. Yeah, so what we know is the median is determine the median score. The median score, yeah. So what we know is here there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 scores in total, right? And we know that the median will be the score in the middle. So if you see here, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, this would be in the middle. So 2x is our answer over there. So we can just move on. I don't know why I'm still on this question, because in my head I'm like, bro, just move on. Just move on. Yeah, let's just move on. So here they say determine the mean in terms of x. So determining the mean in terms of x, remember the mean is just the average, of which for us to get the average, we just have to add everything up and then divide by the number of pieces of data that we have. So for 1 mark only though. Wow, okay. So the mean in terms of x, well, we are basically being asked for the average score in a way, because I mean, like, the scores are the ones in terms of x. So we have technically 4 of these. So we have 4 of x plus 3, and then you add 3 of these, and then you're going to add 2 of these, and then we're going to add 2 of those, and then obviously the total is just 11. So this is just said how this is just out of 1, but you just gotta do what you gotta do. So here we can simplify because it's not gonna hurt us. 4x is the first thing here, and then 4 times 3 is a 12. 3 times 2 is 6, and then here 2 times x, and then 2 times -1. And then what do we have here? So this is 4, right? Plus 6, which is 10, plus 2, which is 12. And then here we have 12 minus 2. No, 12 plus 12 is 24 minus 2. And give you 22 over 12. So you could, I think we can leave it like this, you know? Yeah, let's just move on. So, wait, but how did I get 12 down there, bro? Come on, it's 11, man. Come on now, come on. You're about to mess up just like that. Hey, after doing so well, you are just about to mess up. Yeah, so you see, I might as well just double check what I wrote also, because I'm like, you know, 6, let me see here, 12 plus, let me see here, 2 times, I just want to double check everything to make sure I didn't make a mistake. Yeah, everything's fine. 2, 4 times x, 4x, 4 times 3 is 12. This times this is this, 2x, and then minus 2 plus 12, right? Because we have 2 of the 6's. Yeah, everything looks a-okay. Nothing looks out of the ordinary. Yeah, nothing looks out of the ordinary. But anyways, let's just move on with our question. So it says here 2.3, right? I'm 3.3. If only the scores are taken into consideration without the frequency, determine the standard deviation if it is given that x is a 5. So if x is a 5 and we need to get the standard deviation, we can just use our calculator for that. Because I mean, like, remember, we have 4 sets of marks here. The first one here they gave us as x plus 3. Let me just write them with the x's first. X plus 3, and then we have 3x, and then we have x minus 1, and then we also have 6. So the one thing that we have now is x plus 3, right? X is a 5, so this would be like 8. This would be like 10. This would be 5 minus 1, right, which is a 4. And this is just a 6. So these are the scores. So if you're going to get the standard deviation, you can just get that from your calculator. So in your calculator, right, you're just going to have to press the following. Let me actually just get this. So let's see, mode. And then you have to press, let me see here, mode, and then stat, and then var. So you're going to press here mode in the calculator. Mode, stat, and then you're going to press number 1, which is var. And then a column is going to come out. So in there, obviously, you can just put in these numbers. It's 8, 10, 4, and 6. 8 equal to 10, and then equal to 4, and then 6. Yeah. So you're then going to press the on button. Don't forget to press on, because if you don't press on, then it's most like the data is not going to be saved. So let me actually just do this. Just make an arrow there. You have to press on. After pressing on, you're going to press shift and then the number 1 button. I'm going to press shift here, and then the number 1 button if you're using the calculator, and then it's going to give you this button here, right? We know it has like stat up there, and then from there you are going to have to choose var. var. After choosing var, you're going to have to choose option 3 in the Casio calculator. Looks something like this. And then if you choose that, you're going to get the standard deviation as 2.24. Woo, come on, bro. I ran out of space. So 2.24. There you go. There's your standard deviation. So remember, standard deviation just gives us on average how far each piece of data is away from the mean. So 3.3 was done. Now we'll move on to question 4. Question number 4. Question number 4 looks as follows. I don't think we're going to struggle too much, or at all rather. Looks like a normal quadrilateral. Doesn't look crazy. So the first thing is, they say it here, right? In the diagram below, the coordinates A, where is A? So A is here. And then we have, there's A, then there is C, and then there is B. They say these are the vertices of a triangle in the Cartesian plane. And then they said here, CE, where is CE? CE is perpendicular to AB. And then they said here, E is the midpoint of, where is E? E is the midpoint of straight line CD. So whatever they've just told us now, right? This is important because if this and this is equal, then that's definitely useful in a way. Otherwise, they wouldn't have told us. So next year, for 2 marks, they're asking us to get the gradient of AB. So that's not going to be too difficult or difficult at all, because we're just going to use the gradient formula. So the gradient formula for AB, using the gradient formula AB, we're going to have here y2 minus y1, x2 minus x1. And then that's going to be, let's see, 1 minus 5 is what we can do there. And then we can say 4 minus negative 4. So that would actually be a plus. 1 minus 5 would be like minus 4. This would be 8. So your gradient is a negative a half, which is somewhat expected because this line is, you see, the line is going downwards. So for 4 marks, it says determine the equation of CD. So getting the equation of CD, the one thing that is clearly important is to make use of the gradient that we have just worked out. Because remember, this gradient here, we need it for the gradient of CD because they are perpendicular. Remember, lines that are perpendicular, we know that they are gradients. If you multiply them, they will always be equal to -1. So the gradient of AB, if you multiply it with the gradient of CD, your answer is a -1 because the lines are perpendicular. So this is useful because if we have the gradient of AB, right, and you multiply it with the gradient of CD, which we don't have, we can actually work it out using this equation. So working out this gradient here, we can just divide both sides. Yo, why did I give myself so little space for this question? So for this, yeah, let me just put this over there, right? So for this, we can just divide both sides by -1/2. And then you can just put this in your calculator. -1 divided by -1/2, that's a +2. So these would go away. The gradient of CD is just +2. So since we have the gradient, remember in the equation of a straight line, we can always work it out using this equation, where we just need the gradient of the line and the coordinate that the line passes through. So here, what we know is we have the gradient of CD. We just worked it out. So that's going to give us, that's M. One coordinate that the graph passes through is C. So we can label this X1, Y1. So when we see X1 and Y1, we can just put that coordinate there. So -4, that's actually going to be a +4. Because if you put a minus and a minus there, it's going to be a +4. And here we said it's a 2, right? And then -1, that's going to be a +1. Then I can just simplify. Here, the 4 is going to go over to the other side. So you're going to have 2x + 1 with the -4. We simplify some more, 2x, and then plus 2 there, minus 4. And then 2x, 2 minus 4, right, is going to give you a minus 2. There you go. There's the equation of CD. For 6 marks, they say determine the coordinates of E. So 6 marks, that's a lot. So we need to do what we need to do. But fortunately, it doesn't seem like getting E is going to be difficult, because remember, E is a point where two lines meet each other. So you already have the gradient of CD. Getting the gradient of AB is not going to be difficult because you already have the gradient. So getting the equation of AB is really not going to be difficult, because we have the gradient of AB. We also have a point that the line passes through. Either this one or this one can be used. So we can easily get the equation of AB first. After getting the equation of AB, we can just work out where the two lines meet each other. So let's just do that first. Getting the equation of the line AB, we know we can use the same method here, because here we have our gradient. It's -1/2. A coordinate that the line passes through is just, we can use this one, 4 and 1. So x is a 4, our y value is a 1. So here our x was a 4. Now these are positive numbers, so when we put them here, you will still have -1 here. Here you'll have -4. Simplifying that, you'll have, let's see here, -1, x minus 4. This goes to the other side. And then the next step, -1/2x, positive, -1/2 times 4, -1/2 times -4. It's going to give you a +2. And then here +1, right? And then -1/2x, 2 plus 1 is a 3. This definitely looks believable because somewhere here is like a 5, right? So somewhere there would be a 3, which is fine. So we have the two equations. We can just make them equal to each other and then get an x value of where the graphs meet, and then eventually get the y value. So here we can say, therefore, 2x minus 2 is equal to -1/2x plus 3, because that's the point where the lines meet. I mean, we're equating the two equations because we want to find out where they meet. Here we're going to have 2x plus 1/2 if the half goes over. The -2 goes to the other side. You would plus 3 plus 2 would be a 5. 2 plus 1/2 is just 2.5, but in your calculator, 2 plus 1/2 is going to be 5/2. And then remember, you can easily just divide by a fraction on both sides. 5/2, you divide there. 5/2, you divide there. The answer here is just going to be a 2. X here is a 2. Now we have worked out the x value where they meet. So that's the x value of E. And then to get the y value there, we can clearly just put 2 into any of our equations. So here we can put the 2 in this equation here, just because it's the one I'm looking at. So let's see here. -1/2 times 2 is going to give you -1. And then here, -1 plus 3, that's a 2. So here, therefore, the value of E, 2 and 2. There you go. So nothing crazy there, nothing major. Seems like everything is still in order. So with the next question, right, what are they asking us to do? They're asking us for 4.4 for 2 marks. They said determine the coordinates of D. Where is D? D is a point all the way up there. So D is going to be quite easy. The reason is that D is the other side of the line CD. Now you already have the middle of CD. As long as we have the middle of CD, we can use the midpoint formula to work out the coordinate of D. You see, we can even label this x2 and y2. So what we're going to do is, what we know is that since we have one coordinate here and the middle, this is what we're going to need to do. Remember, your midpoint formula, right, tells you that the midpoint will always be x1 plus x2 over 2, y1 plus y2 over 2. So one thing you can actually do is here, our midpoint were given as E, so that's fine. And remember, we have the midpoint. So meaning you already have what the x value of the midpoint is and the y value as well. So automatically remember the 2 is equal to x1 plus x2 over 2. This other 2 is also equal to y1 plus y2 over 2. So between these two, right, you know that you already have something to put in the equation. Because remember, d is missing. D is x2 and y2. But then you have coordinate c. C, remember, is -1 and -4. So -1 here, -4 there, meaning you're going to have here, this is, we can label this x1 and y1, x1 and y2. So in our two formulas, we already know that here we have x1. x1 is a -1, and then we can work out x2, right? So if you multiply by 2 on both sides here, you're going to have 4. These are going to cancel out. And then you're going to have the -1 plus x2. And then what? This can go to the other side. 4 plus the 1 there is going to give you a 5. There you go. On the other side, same idea, right? We have y1. Why did I put y2 there? Whoops. We have y1, right? It's -4. So here we have -4. And then this is over 2. We can easily multiply both sides by 2. Times by 2 here, times by 2. This is a 4. And then you have -4 plus y2. The 4 here, this goes over, right? So it's going to be 4 plus 4, which is 8. And you have y2 there. There you go. Therefore, the coordinate of D, this is your x value. This is your y value. And then you're done. So nothing crazy, nothing major. We can just keep on moving forward. So with this being said, right, 4.5 says, for 4 marks, determine the equation of the straight line passing through point D and parallel to AC. So without even us worrying too much about the sketch yet, remember, if it's a straight line, we said we can easily just use this formula to get an equation of a straight line. Now, what we know is a straight line basically has a gradient and a y-intercept. So here, you can imagine the reason why they are telling us that it is parallel to AC is because, remember, parallel lines have gradients that are equal. So let's look at where AC is. AC is this line here. So we need to get the equation of a line that passes through D, but that line has to be parallel to AC. So technically speaking, right, with what they are referring to, our line would be somewhere there. This is where our line would be, but it has to be parallel to AC. If they're parallel, it means that their gradients are equal. So we can just get the gradient of AC and use that as the gradient of our line here. And then here we already have the coordinate of D, so that can help us to then eventually get a full equation of the line. So let's get the gradient of AC. Getting the gradient of AC, let me just write it here. The gradient of AC, we know that it would be y2 minus y1, x2 minus x1. Here you can just say 5 minus -4. So you'd actually need to plus -4 minus 1. So it's going to be -4. And you have to plus the 1 there. Let me actually just write this down there. Oh, whoops. Come on now. Cut. Write it down here where we are actually answering our question. So this is giving us our gradient of AC, but it is also the gradient of the line we are being asked to work with. So 5 plus 4 here is a 9. -4 plus 1 is -3. And this is giving us -3 as an answer, coincidentally. But this is expected. We're expecting a negative value because you see the gradient here is definitely negative, and it's quite steep also. So the gradient here is also a -3. So this point here, 5 and 8, can then help us to get the full equation. So here y minus, remember the y value is 8 there. The gradient, we said it's a -3. X value, we know it's a 5. And then here we can just make y the subject of the formula. So here the 8 goes over, comes a plus 8, negative 3. You see now, everything is just ringing all at the same time. All at the same time. Like, goodness, come on, come on. Anyways, so negative 3x, and then negative 3 times the negative 5 there gives you a positive 15. And then you have the negative 3x. 15 plus 8 is going to give you a 23. Positive 23. So this looks kind of strange, right? As a y. No, yeah, it does look kind of strange. But if you look at it nicely, right? If the y value here is a 8, and this line is like super steep like that, yeah, you could expect a y-intercept that is as high as 23. But obviously, when you do get answers like that, you could just take a second to just, double check your answer, see what you're dealing with. But then so far so good. It doesn't look like anything is out of place. Let's do the next question. So the next question is out of 6. It says, determine by showing all calculations whether the y-intercept of the straight line CD also lies on the altitude from A to BC. Yep. You see now. So obviously these are the kinds of questions where you read them once, but you don't have to panic. You obviously do not, you want to read them again. But then you also want to understand what altitude is. But fortunately here they're giving us a mini hint. So they say they determine by showing all calculations whether the y-intercept of the straight line CD. So let's think of it. The x-intercept of the straight line CD. Where's our line CD? Our line CD, did we get its equation? I think we did. Yeah, so let's just get our equation of CD first. Because these are the kinds of questions where you want to read them in installments, and you also then want to answer them in installments. So here we have our equation of CD, right? So let's just get this x-intercept that they're talking about. To get the x-intercept, you'd make y a 0. So here this 2 goes over, and then here divided by 2 on both sides, our x values are 1. Fine, so we have an x value of 1. The x-intercept of the line CD is a 1. There is the x-intercept here. And that point is a 1. Perfect. So what we now know is they then said here, determine by showing all calculations, whether the x-intercept of the straight line CD also lies on the altitude. So it says here perpendicular height. We need to find out whether it also lies on the perpendicular height from A to BC. Let's think of where point A is, or rather, let's actually get this whole sketch here, because I mean, like, scrolling up and down is not useful. So let me just do this. Oopsie. What just happened? Why does it look all stretched out? Come on now. Hey, yeah, nah. Let's do this. Doesn't look very, that looks better. So let's crop it out then. Crop this and crop a dot. Let me crop this. So we have the sketch. Let me actually maybe make it a bit smaller. So this is our sketch, right? Now, where's point A? We need to find out everything. There's point A here, and then the line BC is this line here. So they say determine by showing all calculations whether the x-intercept of the straight line CD, so there's our x-intercept of the line CD, also lies on the altitude from A to BC. Oh, okay. Remember, the altitude is the line from, so in this kind of equation, right, you have to remember you're actually talking about this triangle. This is the triangle that we're referring to, because when they speak of altitude, there has to be a triangle there, because the altitude is the line from the top of the triangle going perpendicular to a specific line, you know. So you can almost think of it as the perpendicular height. Oh yeah, they did say it. They did say the perpendicular height. So yeah, that's the hint they gave us. So they basically want us to figure out if the x-intercept there is a point on our perpendicular height of the triangle ABC. So the triangle ABC, we just need to work out, well, for 6 marks, getting the perpendicular height or the equation of the perpendicular height, that's not going to be difficult. The reason why it's not going to be difficult is because we have this coordinate here, right? Remember, we worked it out. The x value there is a 1, and you can clearly see that the y value is a 0. The x value is a 1 here, the y value is a 0. So we have these 2 points. So we can easily get a gradient. And then we can easily get the equation of the straight line. Because if we have a gradient and at least one coordinate, we can easily get the equation of the line. So we want to get the equation of the line. Wait a minute. This just escalated quickly. Because I'm thinking to myself, wait a minute, dude. We need to think to ourselves, regardless of this being a point on our line, what we actually need to figure out first is, well, let me put it this way. I think the way I drew it, right, it's kind of a bit biased, because I'm already almost like saying that our point is on this line, but we don't know. We're still trying to figure it out. So but let me just leave our line here. So this is not a very straightforward question after all. Yeah, it is not very straightforward at all. But fortunately, we don't need this point here to get the gradient of the line here. Because remember, our altitude will be perpendicular to BC. That we know, because the altitude is the perpendicular height. So if this line is perpendicular to BC, we can just use the gradient of BC. I think we have the gradient of BC. Do we have the gradient of BC? I think so. If we don't have it, we can just still work it out, because that's like super easy to do. Well, we don't have it, but we can work it out. So let's get the gradient of BC. The gradient of BC is just going to be y2 minus y1, x2 minus x1. So you see, we're not using these 2 points to get the gradient, because we are not assuming that this is on the line. What we want to do is get the gradient of this line regardless of this point. So we can use BC because it's perpendicular to our perpendicular height. So here we can just say -4 minus 1, and then -1 minus 4. And then here, this is going to be -5, -5, gradient is a 1. Perfect. So remember, the gradient of BC multiplied by the gradient of the altitude. Let's just put here altitude, just for the vibes. We know that this is equal to -1. So here, remember, if you throw in a 1 here and you multiply by the gradient of the altitude, we know that, I mean, if you divide by 1 on both sides, this is kind of dumb, but our altitude here, the gradient of our altitude is just going to be a -1. I don't even know why I had to do that whole thing, because I feel like everyone can kind of see that, my guy, we get it. The gradient is a -1. But anyways, let's see. I guess I'm just get some space. So with all this being done, right, the one thing that we definitely know is that we have the gradient of our line. So its equation, we can easily work it out using this formula, right? Y minus y1, and then m x minus x1. So remember, we have a coordinate. We can use this one. So the y we can use there is a 5. And then The x there is a -4. So here we have to put a +4. And then here, let's see. This is going to be -x, -4. The 5 we would move it over. It's going to be a +5 over there. And here, this is -x. -4 plus 5, right? That's going to be a 1. Yeah, -4 plus 5 is a 1. -4 plus 5 is a 1. Yeah. So this is the equation of the line. It does look believable. So this is our equation of our altitude. So we now need to figure out if this point is on our altitude. So that point, what we all need to do is to just put x or 1 in our equation and see if it gives us the other value. So here, if you make your y value as 0, let's see if our x value is going to be a positive 1. So this goes over. Yep. So there's a coordinate 1 here and a 0. So the coordinate 1 and 0 definitely is a point on the line. So yes. To answer this question, the answer is a yes, because the question is asking, determine by showing all calculations whether the x-intercept of the straight line also lies on the altitude. So the answer here is yes. It also lies on the altitude. Yo, did I run out of space again? Nope. No, I didn't. Yes. So yeah, that's that for this kind of a question. We shall move on to question number 5. Question number 5, right? It says here, in the figure below, M is a common center of 2 circles. So both circles have M as the center. And then it says here, the largest circle has this equation. So it's not in standard form, but we can put it in standard form for us to get M and also the radius. And then it says here, the smaller circle touches the straight line -x plus 5. And then clearly it is also a tangent. Like we can visually see it. It's a tangent. So remember, these sketches, 99.99% of the time, they are to scale, unless they state they're not to scale. So here it says the straight line y is equal to 0 cuts both circles. Okay, the straight line y is equal to 0 cuts both circles. So it looks like this is one of those sketches where, I mean, if it's analytical geometry, we would expect our sketch to be on some kind of Cartesian plane. But then here they're only giving us the what you may call the line y is equal to 0. So meaning this line here is a line that is basically our x-axis. Remember, the x-axis is technically the line y is equal to 0, because it's a line that's going to be cutting the y-axis at 0 specifically. But anyways, without overthinking it, they want us to give the coordinates of M. We said to get the coordinates of M, we clearly just need to use the standard form of our straight line. So we have to take this equation and we have to put it into standard form. So this is x squared plus y squared equal to 4y minus 2x plus 44. So the big idea is, with whatever we do in these past papers, right? Remember the tutorials to those kinds of questions, you can always check them out on the main channel. The main channel is just Bright Chang Brains. You can always just click on the home page and then you'll see there. You can always just also search for Bright Chang Brains and you'll also see the channel. But anyways, putting an equation into standard form. So from here, you're gonna take everything with y and everything with x to the left. So in doing that, you're gonna have here x squared. You may want to write the ones with x together. So you're gonna put your 2x, ones with y squared minus 4y equal to 44. There we go. Now your next step, you just want to work with the ones with x together, the ones with y together. And this is what you do. The coefficient of x and the coefficient of y, those are the ones you pay attention to the most. Those are the ones you pay attention to the most. So for example, all you're gonna do here is, in terms of you putting all this into standard form, right? The first thing you're gonna do is, for the ones with x, you're gonna have here x squared plus 2x, and then directly next to this, you wanna add this value squared over 2. or rather this value over 2 squared. For the y's, you do the exact same thing. The coefficient of y is just a -4. So you're going to have the -4 over 2 squared. Now, because you added this on the left and you also added this on the left of the equation, you also need to add it on the right side of the equation. So the 2 over 2 squared that we added, we also have to add it on this side. So 2 over 2 squared. And then here the -4 over 2 squared that we added, also have to add it on this side. So once that is done, right, what that does is we're now able to literally take these three terms here. You can just factorize them. If you factorize these three terms, you'll have an x here. Whatever this is, you put that over there. The value inside here, 2 over 2 is a 1. Of which that's going to be a positive 1. And this you squared it. You do the same here also. If you factorize these three terms, right, you're going to have a bracket squared. The y value here, you put it over there. This number, this is going to be -4 over 2, right, which is going to be a negative 2. So you're going to put a -2 over there. And then on the right hand side, all this you put in your calculator. This plus 1 plus 4 going to give you a 49. And then that's it. You technically don't need this. I mean, this here is going to give you the square root of 49 gives you the radius of the big circle, but we don't need the radius. We just need the center, which is going to be given by these two. So our value of m, I'm going to take this as a negative. You have to take this as a positive, because whenever you get the center of your circle, you always have to use the opposite of what is in your equation. So this is m. That makes our life so much easier. So anyways, for the next question, they want us to determine the coordinates of A. So what we know about A is that A is a point on the circle over there. It's also a point of the tangent. And what we know is a tangent will always be perpendicular to the radius of a circle. Now, the easiest way to get A is to get the equation of AM, which we can easily get. And then we need to make it equal to the equation of the tangent. Getting the equation of AM, what we know is, remember, a tangent and a radius will always be perpendicular to each other. So this is already a 90-degree angle. And what we do know is that we need to get, we have the gradient of the tangent already. It's a -1. So we're seeing it here from the equation that has been given to us. The gradient is just a -1. So as long as we know that the gradient of this line here is a -1, it makes our life so much easier, because the gradient of this line here is going to be a +1. See, because remember, the gradient of AM, if you multiply it by a -1, your answer should be a -1, because the two gradients of lines that are perpendicular, you know that they should always give you a -1 if you multiply them together. So here, to get the gradient of AM, you know, you divide this side by -1, divide this side by -1. The gradient of AM is just a +1, because -1 divided by -1 is just a 1. So we have the gradient of AM. So as long as we have the gradient of AM, we can get the equation of AM using this formula. So what we know is M, we have its coordinate from the previous question, and we also have the gradient of the line AM. We worked that out to be a 1. So we can put a 1 there, and then the y value and the x value of our point where the line passes through, we're just going to put the -2, and then here we're going to put the +1. Because if you put a 2 over there, it's going to be like that. If you put a -1 over there, it's going to come out as a +1. Then here, if you multiply inside, you're still just going to have x plus 1. Then the -2, if you take it over, you're going to get a +2 over there. And the equation is just y is equal to x plus 3. This is the equation of the line AM. As long as we have the equation of the line AM, remember the equation of the line AM, we can make it equal to the equation of the tangent, meaning we can then work out where they meet. You see, this is the equation of the tangent. and the equation of the line AM, they meet at A. So here we're gonna have the x goes over to, we can make it go to the left, right? So it's gonna be x plus x, then the y goes over to the other side. You're gonna have the 5 minus 3, which is gonna give you a 2. And then getting the x value of A, you can just divide both sides by 2. Your x value there is just a 1. So once you have the x value of 1, you can easily get the y value by throwing it into one of your equations of your straight lines. So here the x value you can put in as 1, and then we're seeing that the y value is going to be a 4. Fantastic. So therefore the coordinate of A, x value 1, y value 4. Nothing crazy, nothing major. So 4.5.3 says, for 3 marks, determine the equation of the smaller circle. Okay, so getting the equation of the smaller circle won't be too difficult, because remember we have M, right? Negative 1 and 2. A, we have it as 1 and, no, oh yeah, it is a 1. 1 and 4. So the distance of AM is going to give us the radius. So let's just get AM first. The distance of AM, it's like x2 minus x1 squared, y2 minus y1 squared. Remember, with the distance formula, these are interchangeable. If you swap these, you can also just swap those. And then this is under a square root symbol. So here A is 1 and 4. M, it's negative 1 and 2. So with this being said, this is like x1, y1, x2, y2. And then let's see here. We have the negative 1 minus 1, right? So square root symbol there. Negative 1 and negative 1 minus 1 squared. And then 2 minus 4 there. 2 minus 4 squared. And then what do we then have next? This is going to be quite interesting. Well, this is negative 1 minus 1. So it's negative 2 squared. And then negative 2 minus 4 is going to give you another negative 2 squared. So this is just going to give us 4 plus 4, right? Which is just 8. Square root of 8 is going to give you 2 square root of 2. That's the way we like it. So this is the distance of AM, right? I don't know why I made it so big. But no, I don't know why I took so much space, but it doesn't matter, because remember the equation of your circle, x minus a squared, y minus b squared equals r squared. We already have r, it's this value. The center we have it because of m. So we're gonna put there, if you throw a negative 1 over there, it's gonna come out as a 1. If you throw a positive 2 over there, it's gonna come out as a negative 2. And the radius, we said it's 2 square root of 2. And then the whole thing, they just make sure it's squared. There you go. That's going to be your answer. Moving on. They said we should get the coordinates of K. So remember K, according to our sketch, K is a point where the tangent meets the line y is equal to 0. So we have the equation of our tangent and we have the equation of our line. So we just have to work out where they meet. You see, because the one line, the equation is y is a 0. The other one, negative x plus 5. So remember, these two meet at a certain point. So here I'm going to say, therefore, let's just make them equal to each other. So getting x here, you can clearly see x can just move the 5 over and divide both sides by a negative. X is a 5. Because the negative and the negative would cancel each other out here. Nothing crazy. So here we have, remember, this is just the x value. So with k, the x value is a 5, and then the y value is automatically a 0. Because if you had to put a 5 over there, 5 minus 5 here plus 5 would be a 0. But you already have the y value. But That's that for 5.5, right? 5 point, what did I put here? Whoops. 5.5, they say it here, the straight line of this equation, the straight line y is equal to negative x plus 5 meets the straight line y is equal to 0 at k. We know that. They said we should determine the area of AMK. A, we know it to be 1 and 4. So they want us to get the equation of this straight line over here. Getting the equation of this straight line is not going to be difficult because, yeah, it's not difficult because we have the perpendicular height here and we have the base. With whatever you want to look at the base, whatever you want to consider the base of the perpendicular height, it doesn't matter because here we already have the distance of AM. It's 2 square root of 2. The distance of AK, we can work it out using our distance formula because this is 5 and 0, this is 1 and 4. So let's get AK because we need it, AKA. So the distance of AK, as we said here, we can say the x2 minus x1 squared, y2 minus y1 squared, and then these two coordinates are what we're using, right? So let's see, we can say here 5 minus 1, right? Let's see here, 5 minus 1 squared, and here's 0 minus 4, 0 minus 4 squared, and then what? Whew. Okay, this is just 5 minus 1 is a 4, and then here minus 4 squared. There we go. So 4 squared is a 16. This is also a 16. This is just square root of 32, which is just 4 square root of 2. Yeah. Is it? No. Is it? Yeah, because 16 times 2 is what you would have in here. Square root of 16 is a 4. Square root of 2 is just square root of 2. Yep. So that's the answers we would have there. That's the distance of AK. So what we know is in our triangle, come on, bro. In our right angle triangle, right? What we know is, there's not to scale either. Oopsie. Whoops. We have this and we have that. So with our right angle triangle here, we know that this is 2 square root of 2. This is 4 square root of 2. So the area would be a half times the base, whatever you want to consider as the base and whatever you want to consider as the perpendicular height. It actually does not matter. So here this is going to be a half. This you can just all put in the calculator, you see. So 4 times the 2 is going to give you an 8. Square root of 2 times square root of 2 is just a 2. So this is like a half times 16, which is just 8. So the area, yo, dude, come on now. So the area is just 8 units squared. Question number 6, here we go. So it says here, right, if cos 26 is equal to 1 over p, determine the following in terms of p. So say you draw your sketch, do your calculations here. So for this kind of a setup, right, we know that if our sketch technically has to be a right angled triangle. So let us draw a right angled triangle over there. There we go. So this right angled triangle, rather, it doesn't matter how you make it face actually, to be honest. So here now, cos is adjacent over hypotenuse. So you can put 26 over here. Adjacent would be 1, hypotenuse is a p. Adjacent over hypotenuse. So to work out the opposite side here, you can just use Pythagoras. Because remember, p squared is equal to 1 squared plus this, you can label it as y. y squared. And here p squared minus the 1 can go over there, and you have y. So remember, 1 squared is just 1. I mean, 1 squared is just 1, so that's why we're not, making a big fuss of anything here. So here our value of y is going to be square root of p squared minus 1. There you go. So let us just move this. Zing. Uh-oh. Oops. Whoopsie. That escalated. Let's see. P squared minus 1. Fine. So the other thing is you always also want to make sure that your right angle triangle is complete, meaning that's a 90-degree angle. This, we can get this angle here, right? 90 minus 26. It's going to give us 64. There we go. So with all this here now, we can easily work out our 3-mark question. Sine 26 is going to be opposite over hypotenuse. So here, opposite, which is p squared minus 1, hypotenuse p. This, you may think to yourself, can you simplify further? Nope, you cannot. Even though this is just a difference of 2 squares, you cannot simplify further. Moving on. So cos 52, you have to be creative. Cos 52 is double of 26. So clearly we're going to have double angles there. And then here you can change into whichever one of the double angles of cos you want. So let's use the one with a sine. You see, so here we can enable this. This is going to be equal to 1 minus 2 sine squared 26. And then wherever we see sine 26, remember we already know it's this value, but we're going to have to square it. So here we're going to have square root of p squared minus 1 over p, the whole thing squared. Here you can simplify a bit, because you see the top squared, the square root is going to cancel the square, and then the bottom squared, you're going to have p squared. There you go. If you want to go further, you can, because you're free to do so. Multiply inside here. You only have to multiply the top, you see. So these two times the top part, you can have 2p squared minus 2. And then this is over p squared. Yeah, I feel like you could just stop here. But if you want to go a step further, you're going to have the 1 minus 2, because the p here is going to cancel that p. And the other one only has a p there. Because you see, these two, you can write them with this as the denominator individually. So for the 2p squared, it's going to be over p squared. And then this minus 2 is also going to be over p squared. And then the p squared that's there over the p squared that's there, they would cancel each other out. So this is your equation or your answer. You can also technically go one step further. 1 minus 2 there is going to give you a minus 1. Woo! Oh yeah, this would actually be a plus, meaning that this would actually be a plus. Yeah, I'd forgotten that part. Because remember, if you multiply the negative 2 inside, when you multiply the negative 1, this would become a positive 2. Anyways, that's that. So let's keep on moving forward with the next question, right? They said here for 4 marks, we should determine this expression. Yeah, it's part of everything, you see. They said here, if this is given, determine the following in terms of p. So we need to determine this in terms of p. So this is referring to a multiplication symbol. These two are being multiplied together. So obviously we said in our triangle we have 64 somewhere. And when you deal with 10, remember it's opposite over adjacent. So what we already know is 1064 is opposite over adjacent, which is just square root of p squared minus 1. And then this whole thing is squared, right? This thing is being multiplied by p plus 1. P plus 1. Let me actually put this on top. Do that. Do that. So with all this being said, if you multiply, so 1 squared, right, is just the 1. This whole thing here is squared. The square root would cancel the square. So you have p squared minus 1. And then here p plus 1 over 1. Here you have to be careful. Fortunately, at the bottom here, you have the difference of two squares. So here you have p plus 1, p minus 1, because remember, p squared is a square value, 1 is also a square value. And then here, all this is being multiplied by p plus 1 over 1. So as you can see, the p plus 1 up here can cancel the p plus 1 at the bottom there. Then 1 times, this is going to be gone, so 1 will be there as a placeholder. Or let me not do too many things at the same time, you know? Let's just do it simple. 1 times this value will be p plus 1 at the bottom. I mean at the top. This here times 1 will just be p plus 1 here, p minus 1 there. And then here, you know that this will just cancel that. And then your answer here is just p minus 1. I was already, I don't know where my head is today, but that was close. But let's move on. 6.2 says we should simplify. So remember, when you deal with negative angles, right, the one thing to just keep in mind is it's only cos, where if you have a negative cos in there with a negative angle, this is the only one that comes out as a positive cos. Every other one, if there's a negative angle in here, you'll put a negative outside. So for example, for tan, if you have a negative in there, you'll have negative tan like that. For sine, the same thing. If you have sine with a negative value in there, it comes out as sine like that. So here, where you see sine negative b, this is the same as sine with a negative there, and b. Cos 360 minus, remember you can just use the cost diagram here. There's 0, 90, 180, 270, and then 360 here. See? So technically 360 minus. If you go 360 degrees and then you minus, you end up in this quadrant. So in that quadrant, remember C, A, S, T, that's the cost diagram. So C in this quadrant only cos is a positive. So here you have to remember this will come out as a negative sine B. And then at the bottom, let's see, 180 minus. So 180 minus is in this quadrant, sine comes out as a positive. So you have positive sine B. And then here, sine 180, this is where your special angles come into play, because remember, sine 180 is just a 0, because a sine graph looks like this, a standard sine graph. At 360, it's going to be there. At 180, it's going to be there. And at 0, it's there. So you see sine graph at 180, the y value is a 0. So here you're going to have to multiply by a 0 over there, or plus a 0 rather. Woo, okay. So far so good. We can just simplify further. At the top, it looks like we can take out sine b as a common factor. If sine b goes out, it means here you're going to have a negative 1 left as a common factor. Same over there. And then it's kind of weird how I'm doing it like that. Let's not even be strange here. These are like terms. So minus 1 gives you minus 2. Minus 2 sine b. At the bottom, you're just going to have a sine b. You see, because sine b plus 0 is just sine b. And this sine b can cancel that sine b. Then you have negative 2 as your final answer. So for a 5-mark question, you can clearly see this is not a difficult question. We're just going to get a bunch of marks, you know, a mark over there, mark over there, mark over there, mark over there, mark for the final answer technically. So yeah, let us move on. 6.3, right? For 3 marks, they said we should determine the value of P correct to 2 decimal places if theta is 82 and 2p tan this is equal to sine 2p. It's a 3-mark question, and if we're going to be asked to determine this to correct to 2 decimal places, the one thing we can also double check is nowhere in this question did they say we cannot use a calculator. So we are good to go if we need a calculator here. So where we see our theta over there, we can just put 82. So let's see, 2p tan 82 over 2, that's going to give us a 41. So what's this now? Sine 2 times 82 is technically what we're going to have there. Okay. But they want us to determine the value of p corrected to decimal places. So we just need to make p the subject of the formula here from the looks of things. Without overthinking it, we just have to make p the subject of the formula. So we can divide both sides by, let's actually do it all at once. Since we want p as the subject of the formula, we can divide both sides by 210 with this value there. See, do it on the right, do it on the left. 210, 82 over 2. So this 2 cancels that 2, this cancels that. Then you have p on its own. P is going to be equal to whatever this value is, of which this value we can put that in our calculator, because why not? They literally just said give it to 2 decimal places, and we have the calculator, so you might as well use it. So all this in our calculator, let's just put it in the calculator. It is giving us 0.16. So easy mark. The next one says for 6 marks, we need to prove this identity. So if you're going to prove this identity, it says here 4 sine theta minus 3 cubed theta minus 4 cos theta. Sine cubed theta equals to sine 4 theta. Well, obviously, where there's smoke, there's definitely fire, because I mean, like, the 4 is repeating, and the theta, the cube there is repeating. So, I mean, you don't want to take that for granted. So let's see here, the 3 there, and the 3 over there. So one thing that's coming to mind now is I'm thinking of things like, you know, double angles, compound angles, stuff like that. But before even thinking of that, let's see. So do we have a common factor here? Well, technically the 4. There's a 4 here, there's a 4 there. Well, in both of them, there's at least a sine and a cos. Let's actually take out 4 sine theta, cos theta. We can take it out because if 4 is gone and if sine is gone and 1 cos is gone, here you're going to have cos squared theta. If 4 is gone, 1 cos is gone, 1 sine is gone, you're going to have the sine squared theta. This is clearly the left-hand side. So you see, if you're going to prove an identity, you obviously want to work with the side that looks more complicated. So this is the left-hand side. We took out 4 sine theta, cos theta. So if that's gone here, there's cos squared theta left. If that is gone here, there's sine squared theta left. This is clearly the double angle of cos. This looks a lot like the double angle of sine if you take out a 2 from this 4. Well, let me put it this way. Here, let's just leave this the way it is for now. And then clearly here, this is giving us cos 2 theta, because this is the double angle of cos. What I was saying is this definitely looks like the double angle of sine. But for us to end up with the double angle of sine, you have to take out a 2 here, and then here you're going to have 2 sine theta, cos theta. Here you still just have your cos 2 theta. Remember, everything is being multiplied together. So here you can take out a 2, or you can split these up, because now you can visually see, okay, fine, this is just the double angle of sine. So that's just sine 2 theta. So there's the 2 there. This is sine 2 theta. And then this is cos 2 theta. Now, if you look at this nicely also, this is clearly also the double angle of sine. This is where you need to use your creative mind, because creatively, you can see that there's 2 here, there's sine, and then there's like a placeholder, and then cos, and then there's another placeholder. Remember, this is equal to sine 2 with whatever that placeholder is. So if you look nicely, right, where we see 2 theta is where alpha would be. Where we see 2 theta there, this is where alpha would be. So logically speaking, from here, we just have to put 2 theta where alpha would be. This is just going to give you sine with a 2 there. Where alpha is, we're going to put 2 theta over there, which is where you're going to get here sine 4 theta. Then you can say, therefore, left-hand side is equal to the right hand side. There you go. Nice and simple, if I can put it that way. So let's move on to the next question. Okay, so question number 7. What is it? We're working on like the tree graphs clearly. It says that given that f of x is equal to sine negative what? Sine x minus 30, right? And g of x is equal to cos 3x. They say so for x. Wait, what? Given this expression, given these two equations, right? There's the function of f, there's the function of g. They say we should solve for x. So solving for x here, this is clearly us working out where the two graphs meet each other. And it's a 7-mark question. So we would just want to work this out the same way we would work out, a general solution question. And then because we're only solving for x here, it might be a bit simpler for us. So let's see. The first thing here, it says, what do we do? What am I saying? I feel like I'm so distracted. But anyways, let's start here. Cos, do this, make this a bit bigger. Let's see. Cos 3x equal to sine x minus 30. So the one thing I always say is, if you're gonna deal with something with a sine and a cos on two sides of the equation, and you want to, solve for x, you usually want to change both of them into something that has cos. It's just do it like that. Change both of them to something that has cos. Now the one way to do it is, remember, cos 90 minus a value, it is always going to be equal to sine whatever that value is. So what we technically have here is where theta is, right? We technically have x minus 30. So on this side, you would want to put there, wherever theta is, you can put there the x minus 30. There we go. So in our equation, right, where we see sine x minus 30, which is this, right, we can replace it with this based on what we know because of our reduction formulae. So let's actually do that. So here we have cos 3x equal to cos 90 minus x minus 30. There you go. Did we do it correct? Yes, we did. Whatever this is, we changed it to that. Now, the good news is once you have done this, right, you want to automatically split up your page. Once you split up your page, one side, you want to put you're going to drop the cos's, right? So you're going to have 3x here, 90 minus x minus 30. On the other side, you do the same, but then make sure that this right-hand side, you multiply by a negative. The reason why I'm doing this is, as long as you're working with cos, it makes your life so much easier. Because as long as you have changed both of them to cos, you always need to keep in mind that, remember, what you know about cos is that cos with an angle there is equal to cos with that angle as a negative. So this is going to allow you to get multiple answers. Because you remember, wherever this cos was, right, you know that this whole thing here, you're looking at it as a positive, and that same whole thing, you're looking at it as a negative, because we know that that's how cos works. That's why I always say change everything to cos, because it's easier for you to get all possible answers. So on the left-hand side here, let's see what we can do on this side here. So here we're going to have 90, and then if you multiply a negative here, you can have negative x. Here you can have plus 30, and then here this is like 3x. And then here, 90 plus 30, right? That's just 120. And this is like 3x. And then everything with x to one side, this is going to be added to that. And then divide both sides by a 4. What are we going to have there? If you divide both sides by 4, excuse me, x is a 30. And then since we're just solving for x, this is fine. Here you do the same, you see. So 3x is going to be equal to, if you multiply inside, let's not multiply inside yet, right? So minus the x here, and then plus the 30. And then here you're going to have 90 plus 30. What is 90 plus 30? 90 plus the 30 is also going to give you a 120. Yep. So this is going to be 120 minus x. And then you have 3x over there. And then here, if you multiply inside, you have negative 120 plus x. And this is like 3x. So you can take the x to the other side. This is going to be 3x minus x, right? So it's going to give you 2x. And if you divide both sides by 2, the only issue is that, remember, this answer does not qualify. Does it qualify? Yes, it does, because they said we should take answers from negative 60 to positive 180. So yeah, this qualifies, and the 30 also qualifies. But the funny thing is, when you're going to be solving for x, right? Obviously, the two answers that we have here, it doesn't look like anything is, wrong. Everything looks 100% fine. But then you definitely do want to ask yourself, could we potentially have, other x values? So that's why, even though you're not asked for like the general solution, with these answers, right, you always also want to make sure that as you're working them out, right, before you find yourself dividing by anything, you want to put there your plus k360. K is element of integers. So here you can put that over here, plus k360. So meaning here your plus k360, right? You would have divided that by 4, meaning here you'd have plus k90. Let me just write these a bit better. Woo, red is not the nicest color to write with, but I guess in this case, it's going to make the point. So here plus k360, you would have divided by 4. Here you'd have the plus k90. Then here you'd have divided it by 2. So here you'd have plus k360 divided by 2. Then here you'd have plus k180. So even though you're solving for x, right, you want to have that there. The reason is when you're done with your answers, for you to get other valid answers, right, wherever k is, you're going to just throw integers there. Like, for example, this side here, let's say let k equal to 1. If k is a 1, you're going to have 30 plus 1 times the 90, which is just going to give you 120. Of which, if you look at it nicely, 120 is definitely between the two values here. So 120 is a valid answer. If you were to try at 2 times 90 already gives you 180, and then 180 plus 30 is a number that's too big. It's not within this range here, or this domain rather. Here you can try the same thing. If you make k a 1, you would have the 180 minus 60, which would give you 120. You already have 120. If you make k 2, you'd get an answer that's too big. So these are your 3 values for x: 1, 2, and 3 over there. That's how you would get your whole 7 marks. If you had just left these two as the only answers, you probably may have gotten like 6 marks. So I mean, like, why get 6 when you can get 7? So let's move on. 7.2 says, for 6 marks, right? Draw the graph of f and g from negative 60 to 180 on the grid provided. There's no grid here. So if you're gonna draw any graph, right? Let's just do this. Let's just do that. Ooh-wee. Oh well, so here we are. We need to draw our 2 graphs. I don't know why I made this so extra. I need to draw from negative 60 to 180. So let me just actually draw the x-axis first, because the x-axis is actually the important thing. The y-axis is not that important actually, but meh, it's fine. So if we're gonna put negative 60 over here, let's maybe make this go in 30s. Normally intervals of 30, they are okay for trig graphs. So if you make all this here like a negative 60, right? Let's say here this is going to be a negative 30, and this is a 0, 30, 60, 90, 120, 150, 180. Okay, that's not bad at all. So with this being done, we can easily then now draw our y-axis over there. Whoa, Brody bro, come on. There we go. So with this being, this is our y-axis, right? Up here, this is our y-axis, this is our x-axis. So if you're going to draw your two equations, right, this is where your knowledge of your standard equations come into play. Because remember the first graph, the graph of what? Let's see which graph here. The graph of f of x, right? Let's see what f of x looks like. We have f, and then they told us it is equal to sine x minus 30. So all you need to do is, for something like this, right, you need to be able to recognize, what kind of a graph this is, or you need to recognize what has happened to a standard form. So remember, a standard sine graph, if we were just thinking of the sine graph sine x, the graph sine x, let me just write here, y is equal to sine x. If you think of y is equal to sine x, we already know that there is 0, and then it goes all the way to like 1, right? And then it goes all the way down to like -1. At 90, we know it's at +1. At 180, we know it's at 0. And then on the left side, yeah. This is what the equation y is equal to sine x. From 0 to 180, we already know that it's just going to have like a hump like this. Then on the left side, we know it would just have something like this, you see. Now the issue is, this is the graph of y is equal to sine x. This graph is the graph of sine moved 30 degrees to the right. So you see, this here is a shift 30 degrees right. That's what has happened. So what you then want to think to yourself is, if your whole graph is moved 30 degrees to the right, then technically speaking, these key values here, the 180, right, we won't be able to see it, but if it's moved 30 to the right, this point would be somewhere there. The 90, where this turning point would be, if it's moved 30 to the right, it would be somewhere there. The 0 here, if it's moved 30 to the right, this is where it will be. So you can now think to yourself, you see, if it's going to end somewhere at 180 here, right, the curve would have gone like this, you see, but then at 180 it needs to stop. So you can already think to yourself, you would see something like this. And then on the other side, remember this here was supposed to turn somewhere at negative 90, but now it would be turning at negative 60, you see, because if you look at it nicely, right, your graph was supposed to, from 0 to 360, this is what it looks like. 180 is like somewhere there, and then your turning point is somewhere at 90 over there. The other side, the turning point would be somewhere at negative 90. But then if the whole image is moved 30 degrees to the right, instead of it turning at negative 90, it would turn at negative 60, because everything would be moved 30 degrees to the right. So let me remove this blue graph here. It was just there to show how they expect you to draw these equations or these graphs here. So that's the equation of f of x, right? So we can just label this one f of x. So let's do this, make this bigger. Let's do this, let's say here f of x. Perfect. Drawing the graph of g of x is going to be a bit easier than the graph of, maybe almost the same, Because the only thing we need to recognize is that the frequency here is a 3, meaning in a space of 360 degrees, we would be expecting to see 3 graphs. So what that means is, let me just show you what it means. In a space of 360, we were supposed to see 3 graphs. So meaning, if there is 360 here, right? 360 cut into 3/3, you'd have 120 over here, and then here you'd have 240. Meaning after every 120 degrees, you should be expecting to see a full course graph. Meaning you would have something like this, and then you would have another course graph, and then you would have another course graph like that. So obviously this is not to scale, but I think you get the idea. So what you need to keep in mind is a standard course graph, right? Between 0 and 360, a standard course graph, you want to take note of certain key values. So between 0 and 360, what we know is there's 0 here, there's 90 here, there's 270 here, in the middle here there's 180, and then at the end there's 360. So what happens is, if the frequency is now at 3, g of x is equal to cos 3x. If your frequency is now at 3, what that means is, you see these key values here, 0, 90, 180, 270, and 360. You want to divide each of them by a 3. So, I mean, 0 divided by 3 would still just be a 0. But then whichever way, firstly, what we know is the graph of G and the standard course graph, they also still have they both have an amplitude of 1. So we know that this graph still goes between 1 and -1. The graph of G would also go between 1 and -1, because the amplitude here is a 1. So the idea is, as we said, what you want to do for yourself is you want to see what this image would look like, right? If it has a frequency of 3. We know this is what it would look like. Between 0 and 120, you'd have a full graph. Now, this value here and this value, and also like the x value of the turning point, and then where it ends, for you to get those key values here, all you have to do is to multiply, you have to divide each of these values by 3. You see, so we know that where it would start, it's still going to be starting up here. Let me maybe make it in red. It's still going to be starting up here, right? But then it would have turned at 90. So now you're going to say 90 divided by 3, which is a 30. So it's not going to turn there. I mean, it's not going to cut the x-axis there. It would have turned at 180. So you divide this by 3. 180 divided by 3 gives you 60. So it's going to turn down there. 270 divided by 3 gives you a 90. 360 divided by 3 gives you a 120. So your graph would look something like that. You see, and then you can see that this is just, you can easily see after every 30 degrees. That's where we have these key things happening. So meaning here, 30 more degrees, it would still come down like that. And then 30 more degrees, it would do that. And then since it's supposed to end at 180, that's all we have. On the left side, 30 degrees, it would dip like that. 30 more degrees, it would need to, like, you know, do this whole thing. And then we can see this is matching up to our 7.1, because 7.1, we found out that they're equal at -60, at +1, at +30, and at +120. So these values here are definitely matching up with, you know, with what we got. So for 7.3 now, let me just try and give an idea. Let me just label these here. So here we say this is g of x, right? Which is just cos 3x, and then this would just be a random course graph, or a standard course graph in a space of 0 to 360. So here we drew f of x, and we labeled it. So let's just also label g of x here. 7.3 says, use your graph and your answers to 7.1 to answer the following question. So you have your graphs here. Perfect. Our 7.1 was where they meet. So here they said, for which values of x is f of x multiplied by g of x smaller than 0. Well, remember, this is just saying you're taking one expression multiplied by another expression, or rather one value times another value. Where is that going to give you a number smaller than 0? So what you know is this is just saying the y values of f multiplied by the y values of g. They want to work. They want us to give where will those be giving us a value that is smaller than 0 if you multiply them. Now, the way you want to look at this question is you want to think to yourself, okay, fine. Firstly, when two things are being multiplied together, the only way you're going to have an answer that is smaller than 0 is if you're multiplying one thing that's a positive and one thing that's a negative. Or this is the negative, and then this would be the plus. The whole point here is you would need to multiply two things where one is a plus and the other one is a negative. So here we're dealing with y values of g and y values of f. So all we have to do is our sketch, we just have to look out for cases where our graph of f has positive y values and where does it have negative y values. Same for g, we have to check where does it have positive y values and where does it have negative y values. And then after that, we can worry about this. So for now, let's go to our sketch. If you look at our sketches, right, or our sketch rather, let's give ourselves two colors, blue and orange. Blue, let's make that where our graphs have a positive y value. Let's start with the graph of g. The graph of g has positive y values over here. Or let me just actually copy this image so that I don't ruin this one. Let's take this image over here. Copy. Down here, let's paste. Ooh, okay. Very nice. We actually need the whole sketch actually. So if you look at our image, right, we want to focus on cases where, let's firstly color in the parts where our graph of g has positive y values. So our graph of g has positive y values over here, over there. That's where it has positive y values. Same as over here and over there. So now let's also then put in blue the parts where our graph of g has positive y values. So this has positive y values over here. This has positive y values over there. Nah, that's actually, because I'm thinking if we put it both in blue and or yeah, let's just do it. So this is blue part, positive y values, blue part, positive y values. And then the orange part, let's put in the negative y values. So negative y values of g, negative y values of g, negative y values of g. And then here you also have negative y values of f. So now when you're going to answer your question, you want a specific spot on your sketch where you have one graph having positive y values while the other one is having negative, and then vice versa. One is having negative y values while the other one is having positive y values. So before you give your answers, right, you want to firstly take note of the x values where your changes are happening. You see, because here at negative 30, that's where one graph goes from positive to negative. Here at positive 30, that's where we also have one graph going from positive to negative. Here at 90, we have the same idea there. At 150, we also have the same thing going on there. And then, I mean, like here, this is where our image ends. So we might as well also put like, you know, something there. So literally now with these lines here, you can easily answer your question, because if you look at your question nicely, between negative 30 and this positive 30 here, one graph has positive y values while the other one has negative y values. So that definitely qualifies for our answer. So here we can say x is the element of negative 30 until positive 30. The reason why we're putting round brackets for the negative 30 and the positive 30 is because specifically at negative 30, right, one of the graphs is equal to 0. And then specifically at positive 30, one of the graphs is also equal to 0. So remember, we know that our expression needs us to be multiplying two values, and we need to get something smaller than 0. So if one of these is equal to 0, then anything times 0 is a 0. So that's not a number smaller than 0. That's why here for our answer, we have to exclude specifically the negative 30 and the positive 30, because specifically like at negative 30 here, this y value of this graph here is a 0. And then specifically at positive 30, they both have a y value of a 0. So that would not, if we put those y values in our expression, they won't give us a number smaller than 0. But then anything before that, anything between that, it works out, because this is on top, these y values are positive, these y values are negative. This portion here also qualifies, because here you see these are all positive y values for one graph, and then these are negative y values for the other one. So our other answer here, we're going to have to say x is the element of 30 until 90. Also round brackets, because you see here there's a y value of 0, there's a y value of 0. And then this part does not qualify because they are both having positive y values. And then here from 150 to 180, that part qualifies. So here x is element of 150 until 180. The fortunate thing is here, the 180 has to be included, because this is still going to be a negative y value, and then this would still be a positive y value. So those two values specifically at 180, those would work, because none of them is a 0. So these are the answers you'd give, and then they're going to give you 4 marks for that. So you can see this is the kind of a question where you don't have to do any calculations. You need to use your sketch, which is what they said. You see, use your sketch. And then also they said we should make use of our 7.1. 7.1 is basically just making use of where they meet over there, and over there. So that's really not a issue. So that's that for 7.3, right? 7.4, we don't have a 7.4. So let's move on to question number 8 then. Question number 8. So with something like question number 8, let's see. It says in the figure below, PQR S. So there's P, Q, R, and S. This is a straight road. And then they say TQ with TQ here, which is another road, is perpendicular to the road PQRS. And then they say that the distance RS is equal to D. And then they said T1 is equal to T3. And then they said here QTS is beta. QTS is beta. Yeah. QTS is beta. So if this angle here, QTS, is equal to beta, so the whole thing is beta. Okay, fine. So for 1 mark, they say write down the size of QTR in terms of alpha and beta. So that's not too bad, because this angle here, which is what they're talking about, is just going to be beta minus alpha. Beta minus alpha. That's what QTR is. Nothing crazy there. And then for 1 more mark, they said here, in triangle SQT, write down the size of S. SQT. This SQT, they want us to write down this size. So this one is not going to be too difficult either, because clearly we have to write this in terms of alpha and beta also, because nothing is given here. But we know that this is a 90-degree angle also, because they told us that these lines are perpendicular. So if one side is 90, the other side is also a 90. So we know that getting the angle of S, we can just use interior angles of a triangle, because we're dealing with this whole triangle here. So in the triangle, we know that S is going to be equal to 180, minus this, and then minus beta. So let's see here. S is equal to 180 minus 90 minus beta, which is clearly going to remove this here. This is beta. This is going to be 90 minus beta. This is what angle S is. Yeah. So this is also one of those questions where we definitely can only write it in terms of beta or alpha. We don't have an actual size yet because we technically can't. So anyways, moving on. For one more mark, they said in triangle PQT, write down the size of P. Yeah, okay. Let's just put our angle beta here so that we have it. And then in this case, they're asking for angle P, which is this angle here. Same idea. This we're going to say 180 minus 90 and minus alpha. That's what our P is going to be. So here P, 180 minus alpha minus 90. It's going to be 90 minus alpha. That's angle P. So that doesn't seem like it's a difficult question. Let's move on. For 3 marks, I determine the length of RT in terms of alpha and beta. Even though it's not like an actual length, right? As long as there's D in our sketch, you want to use it as though it was a length given. You see? So the only way we can make use of D, right, is if we make use of this triangle here, the triangle RTS. This is the only viable triangle to use. Because the more I'm looking at the question, the more I'm like, but wait a minute. D is not an actual length given, but we have to make use of it as though it was an actual length given. So remember this here, we worked it out to be 90 minus beta. Beta, bro. Beta. This tiny one was given as alpha. And then here, technically, if you think of it nicely, this would be technically this would be 90 plus this angle, because an exterior angle of a triangle is equal to the sum of the opposite interior angles. You see, because if you look at this right angle triangle here, right, the angle here is R2, right? This is R2. So what you know is that this here plus that should give you that whole angle. So R2 is just 90 plus beta minus alpha. So let's just do that. R2 is just 90 plus beta minus alpha. And then let's see here. So what is this thing now? Yeah, so I think here there's no way to simplify this any further. So if you're going to work out the length of RT, right, you can just use the sine rule, because here you want to work out RT, and then the angle opposite, this is the side RT, right? The angle opposite RT is this one, 90 minus beta. And then you can use D and the angle opposite D. So here it's going to be D, and then sine the angle opposite D. And then what you got. So if you cross multiply, let's see, this times D, right, is going to give us D sine 90 minus beta. Cross multiply, you're going to have RT sine alpha. Since you want RT as the subject of the formula, you can divide by RT on the left and on the right. And then you're going to have the sine alpha. No, what am I saying? I want to work out RT, bruh, so we should divide both sides by sine alpha. Yeah, ne? Sine alpha and also sine alpha. So you're gonna have here this cancels that. Therefore, your value of RT is equal to D sine 90 minus beta sine alpha. That's the way we like it. Yeah, that's about that. If you want to go a step further, remember 90 minus anything can be changed to a cos if you're coming from sine. And then because 90 minus will give you a positive, this is what you can have. There you go. You're going to get 3 marks for that. So this is one of those vague questions, to be honest, because, yeah, but it is what it is. We are done now. For question 8.5, it's starting with the hence. They said hence or otherwise show that RP is equal to that. So in this kind of a situation, I mean, one way or the other, we would just need to think to ourselves, we should just get RP. RP is this whole line there. So fortunately, I mean, like, it only makes sense that we make use of this triangle, the one with RT here, because we just worked at RT. Then there's PR that they're looking for. So RT we have, it's D cos B sine alpha. And then PT, we don't have anything for PT, so we might as well not worry too much about it. But we have the angles, right? Remember, this angle here is 90 minus alpha. This one there is just 90 minus beta. This one down here is technically, remember, this is like beta minus alpha, right? And then this is alpha. So the whole thing here is just this angle plus alpha, which is just going to give you a beta. This angle is just beta. You remember we also did it in the previous question. Yeah, here I see P, T, R is this angle here plus that angle, which is just a beta. So in this triangle here, we have all the angles and we have one side and we're looking for this side. So it looks like getting PR, we may have to use the sine rule again. Why am I thinking of the sine? Because we have an angle here, the opposite side is missing. We have an angle there, the opposite side is given. So we might as well use the sine rule. As a formula, we can say PR here over sine T is equal to TR over sine P. Okay, so it looks like is all good. So PR here, that's what we're looking for, right? So we're probably going to have that as the subject of the formula. And then here sine, our angle here is a beta. TR is this big thing here. So here we have to be careful because remember, if you have a fraction, right, divided by something, the denominator of your fraction is where this would go. Let me say that again. We have TR, right? TR is D cos beta over sine alpha. And this fraction is being divided by sine P. Remember, sine P would technically be, remember here, if we're thinking of this angle here, sine P is equal to sine 90 minus alpha. So this sine P here, since we're saying this value, which is this whole thing, divided by sine P, as long as you have a fraction divided by something, whatever you're dividing by, you just have to put it at the denominator of your fraction. You see, like that. So when you're simplifying some more, here, we can just deal with this actually. We can actually just multiply both sides by sine B, actually. So multiplying both sides by sine B times by sine B, we have here, this cancels that, and then PR is here, right? This is going to be D cos B sine B, and this is sine X, sine alpha. Here, remember, this is, you can change this from your reduction formula. Remember, anything with a 90 tends to a cos, and then anything, sine 90 minus, everything is a positive in that quadrant because CAST, everything is a positive in this quadrant, which is where 90 minus alpha would be. So from sine, you have to change to cos, and this is what we have. If you look at it nicely, it's exactly the same as what they want us to end up with. You see d cos beta, sine alpha, cos alpha. Will give us 3 marks. And that is that. Let's move on to question number 9. Question 9. This one is it's looking quite interesting. So question number 9 says the following. It says here, complete the statement, right? The angle at the center of two, the angle at the, oh, I already said, I already completed this because it says the angle at the what is equal to 2 times the angle at the circumference of the circle. The reason why I already said center here is because I had already seen this whole 2 times angle what. Because the statement says anytime you have an angle, right, at the center of the circle, it will always be 2 times the angle at the circumference. So here it says in the diagram below, O is the center. Let me just maybe use a brighter color, yellow. So O is the center, right, of the circle with points A, B, and C on the circumference of the circle. And then they said BAC is equal to X. And then you have OBC. OBC is equal to X over 3. So this is X over 3. And then one thing we can already add is that, remember, this is the radius of the circle, this is the radius of the circle. So by default, this is also X over 3. We can just let them know we know that when we will need it. Then they say to determine with reasons the value of X. Well, whichever way, this is X, right? It means that this is equal to double X. So that's 2X. So we have 2 things here that we have added, right? And you can see here, this is a triangle. So all the angles in this triangle have to add up to 180. So let's firstly tell them we know those 2 things that we have just added onto our sketch. So here BOC is just 2X. The reason is angle at center. The angle at the center of the circle is double the angle at the circumference. Here we're going to say OCB, or rather, let's just state that OB is equal to OC. The reason is radii, because they are both the radius of the circle. So the moment we have told them that these are equal, we can easily say, therefore, OCB is also equal to X over 3. The reason there will be angles opposite equal sides. So now we can easily then say our final statement before getting the answer. Here we can then say X over 3 plus another X over 3 plus the 2X there. They need to give us a 180. The reason is interior angles of a triangle. So here now, these 2 added together, right? It's 2 of the same thing. So we have 2X over 3. And then 2 times X is just 2X over 3 plus 2X. So here you have to be careful, you see, because you're just saying 2 over 3X plus 2X. So you can actually just use your calculator, because this here, you just want to see it as 2 over 3X. You see, 2 over 3X plus 2X. You can just put 2 over 3 plus 2 in your calculator. So 2 over 3 plus 2 in your calculator. Let me see what that's going to give us. 2 over 3 plus 2 in the calculator, that's just 8 over 3. So 8 over 3X, right, is what we are seeing over there. So 8 over 3X is equal to 180. Fortunately, even though you're working with a fraction, you can still just divide by a fraction on both sides. 8 over 3 here, 8 over 3 there. And then this cancels this, x here is equal to 180 minus 8 over 3, right? I mean 180 divided by 8 over 3. We can just use a calculator for that. So using a calculator for that, we are getting 67 over 5. And then yeah, we didn't exactly do any heavy lifting over there, so that's fine. And then let's see here. Question 9.3.1. This is what 9.2. So 9.3 here, it's more Euclidean geometry, as we can see. It says in the diagram below, O is the center of the circle passing through A, B, C. So the circle passing through A, B, and C, right? But then it also passes through M. So this is a cyclic quadrilateral. Then they said K is the center of the what? K is the center of the circle, or the circle is not drawn, but that circle passes through points A, B, and C. Wow. So we can actually draw it for ourselves because, yo, why not? It's a weird looking circle, but it says here K is the center of the circle passing through points A, B, and C of triangle ABC, such that K lies on the radius BO. Then it says A1 is 30. Then they said BO bisects A, B, C. So these two angles are equal to each other. But the circle that they're talking about would do something like that. Wow, that's a strange looking circle. If it passes through those points, right? Yeah, I mean, like it would need to look something like this. Yeah, let's do that. Wow. Well, we can always like draw that circle whenever we need it, you know? But anyways, the things that they mentioned, yeah, they mentioned quite a lot. They also mentioned they mentioned that the line BO, right, bisects this angle. So this part here is equal to that part because that angle ABC is cut in half. They told us there. If this is 30, automatically this is 60 if we ever need it. And they say this is the radius of the circle. So when they tell us this bluntly, that's, you know, information they don't have to tell us. But the moment they tell you, you know, you want to be grateful because that's useful. So this tiny angle there is equal to this tiny angle over there, which is equal to that tiny angle over there, because that's information, you know. This is, if it's equal to that, these are equal because, you know, I mean, the whole thing here is equal to the whole thing here because angles opposite equal sides, meaning it's going to be equal to that whole thing over there, you see, because these are equal. So let's not analyze too much. Just enough is okay for us to start, because for 5 marks, they're saying determine the size of B1. Give reasons for your answer. So you see here, they're asking us to determine the size of B1. I mean, the last thing you want to do is to focus on B1 because based on everything we've written, we have already gotten B1. Because for us to get B1, we just need to at least get one of these other yellow angles, of which those are much easier to get because this is 60. So let's start with the 60. Let's tell them we know this is 60. Then we can use this triangle and use interior angles of a triangle to get each of these. Then we can just tell them that these are equal. So whatever this is, it's going to be equal to B1 because B1 is equal to B2. That's a given. Well, let's do it step by step. Let's get O as 60, right? Let's tell them here O is equal to double of A1. The reason is angle at center of circle. Therefore, here O is equal to 60. That's the first thing. Secondly, we need to tell them that OB is equal to OC because they're radii. OB equal to OC radii. So therefore, C1 is equal to B2. Therefore, C1 is equal to B2. The reason is angles opposite equal sides. So we have told them that C1 is equal to B2. Now we need to tell them that B1 is equal to B2 because that's given. B1 is equal to B2 given. So we're trying to just lay out our information. We have now given them the information that all these three angles are equal. And we have told them that this is equal to 60. So all we need to do is to get the size of at least one of them. And then we'll have B1. So to get C1 and B2, that's going to be easy. So here we can then say, based on everything we've stated here, we can then say, therefore, B1 is equal to 180 degrees minus 60 divided by 2. The reason is interior angles of a triangle. So here, this is going to be 90 minus 30, which is just a 60. What a wow. So automatically here we're dealing with the equilateral triangle, because if this is 60 and this is 60 and this is 60, all the angles are equal and all the sides are equal. That's the logic behind what we have just done. But anyways, this is just 60, it's fine. So here we can then say, no, let's just say B2 first. B2, because B2 is what's in here. That's the logic. We can only use interior angles of a triangle if we're talking about B2. So with everything being said, we can then say, therefore, B1 is equal to 60 degrees. You see, because it's equal to B2. So you can see this is a 5-mark question because you see a lot of the stuff here. You see angles at the center, angle at the center of a circle, red eye, isosceles triangles, information given, interior angle of a triangle. So all that is going to add up to your 5 marks. So for 3 marks here, they say we should prove that M is equal to double of A1. Where is M? M is this angle here. So the fortunate thing about M is that M is, you see, the opposite side of our isosceles. I mean, it's the one side of our cyclic quad, and we have already said that ABCM is a cyclic quad because all the points are already touching the circle. So that's what makes it a cyclic quad. So opposite angles of a cyclic quad, remember, they're equal. So it looks as though if we can just get information this side of the sketch, we can whichever way, we already know what this angle is. This is 60 plus 60, that's 120. So 120 plus this angle should give us 180 because opposite angles of a cyclic quad add up to 180. So this, we told them that it's equal to 60. This, we told them that it's equal to 60. So we can just tell them ABC is equal to 120. Proven. ABC is equal to 120. Proven. And then here you can just say ABC plus M. This is equal to 180. The reason is opposite angles of a cyclic quad. And then ABC, right? Remember ABC, we worked it out to be 120. Angle M we don't have, but then now we can work it out. So M is going to be 180 minus 120, which is a 60. You see, therefore M is double A1 because A1 is a 30. 60 is double 30. That's that. So let's move on to question number 10. Question number 10. Question number 10 is yeah, it is what it is. Question 10 says the following. In the diagram below, there's P, there's Q, there's R, and then they say these are points on a circle, yes. Then they said YR bisects PRQ. Where is PRQ? PRQ. So they say YR bisects that angle. So yeah, these two angles are equal to each other, just like the previous question. But anyways, let's just highlight these dots. This dot is equal to this dot. And then they told us that YR bisect PRQ, with Y on PQ. Yes. PQ is produced to meet RS, yes, at S such that SR is equal to SY. So if SY is equal to SR, it means that we are dealing with an isosceles triangle there. This line is equal to that line. You see the whole thing. So let me actually maybe put it like here. I see this line is equal to that line. Okay. So whatever that angle is, it's going to be equal to whatever this angle is. And then they told us that all this is produced. No, PQ is produced to meet PR at S such that these are equal. And then they said QX, where's QX? QX is parallel to that. Okay. So we have parallel lines. Yo, looks like there's a lot of information here. So here they said prove that SR is a tangent to the circle at R. How? 10 chord theorem. Wow, man. This is so dumb. Like, seriously? Why are they asking us to prove the 10 chord theorem? Like, it's like so weird. It's like, what? Really now? Prove that SR is a tangent to the circle at R. Well, they didn't tell us it's a tangent. Okay, fine. So we should prove it. Well, yeah, as we're saying, if you're going to prove that that's a tangent to your circle here, I mean, you're definitely going to have to just prove that this angle here is equal to whatever this angle is over there. So, yeah, we have to be a bit creative. So, I think I should have rubbed out, some of these things here on the sketch that were not originally there. You see, like something like how this was not there, this was not there, this being labeled Y was not there, but it looks like we're probably gonna put it back because it's like, that looks very useful. We might as well steal that. We'll see what we can do. So whichever way, right? The information that they gave us is more than enough for us to prove whatever they want us to prove here. Because the fortunate thing is that whatever they want us to prove here, we're definitely going to make use of the information they gave us. Now, as we said, right, if you're going to prove that this line is a tangent, then you have to make use of the fact that you just want to prove that this angle there is equal to that angle there. So the way you can do that, obviously, you can label these angles. You don't have to label them, actually. So you can just state what we need to prove. So we have to prove that R3 is equal to P. So that's what we have to do. So you proving that R3 is equal to P. The fortunate thing is all you do is get an angle equal to P and then get an angle equal to R. Fun enough, those two angles would most likely be equal to each other, or it would most likely be the same angle. So what I mean is try and find in your sketch things equal to PR. The first thing that's blunt is Q2 because of alternating angles. You see, PR is equal to Q2. PR, P3 is equal to Q2. The reason is alternating angles. So now that you've found out that Q2 is equal to R3, what you can actually do is to try and find something else that is also equal to Q2, one way or the other. So if you cannot easily find something that is equal to Q2, what you can do is, let's think of our angle P there. Let's try and see what can be equal to our angle P. We cannot bluntly see what is equal to P immediately, but yeah, I feel like that whole X and Y thing is definitely probably going to be useful because this was like there on the on the question paper. I think someone had like made notes and stuff. But let's see. This angle is equal to that angle over there. What we know is that in this circle here that they told us, we don't know anything about, you know, this line being the diameter. They have not told that to us, so we cannot use it as the diameter. We know that this line is equal to that line, so that big angle over there is equal to that big angle over there. Okay, I think we have to make use of the information that we have. I mean, labeling this may help us, you see, because if we label this x, then it means that this is going to be equal to x. And then we can label this whole thing here y. And then this whole thing here would also be, come on, bro, come on. Let me not try and make this complicated. Let's just try and keep it simple. How many marks is this? It's a 6-mark question. So yeah, we have to think strategically. The other thing is, you see, R1 is equal to R2. So we could label these the same thing. I think that would help. Let's say here, let R1 and R2 be equal to Y. So if we label this Y and we label this Y, and then let us label R3. Let's make R3 equal to X. If we label this X, right, I think we will be in a good spot, because this is what I'm trying to do. We have an isosceles triangle here, right? So in the triangle RSY, we can get Y2. The moment we get Y2, we know that if we have a value for Y2, remember this value for Y2 is equal to the sum of the opposite angles of this triangle. You see, because remember, an exterior angle for triangle is equal to the sum of opposite interior ones. This is automatically going to be x plus y. So if this is x plus y and this is y, it means that this automatically has to be x. And as long as we can show that this is equal to x, it means that it will be equal to that. Let me not put a green there, because it's gonna, the green there is looking like an angle we have already labeled in green. So let me just remove this here. Let me use a purple. Purple. Yeah, purple. This big angle here is equal to x plus y. Or let me just write this bit by bit so that we don't, get confused unnecessarily. So with all that we have done here, you see, we've said let R1 and R2 be equal to y. R3, let's make it equal to x. So with that being done, right? Fun enough, this statement here, it doesn't look like it's gonna help us much. So, but we can leave it. Let's just leave it because we really don't need it, but let's just leave it. So here we said here, y2, right? Y2 is going to be equal to R2 plus R3. R2 plus R3. The reason is angles opposite equal sides. I don't know, I'm writing so big. But anyways, with all this being said, right, this makes our life so much easier, because now we just have to say y2 is equal to R1 plus P. R2, or let me just make a conclusion here. As long as this is equal to this, it means that y2 is equal to x plus y. There we go. So that's the first pit stop. The next thing we have to write down is that y2, oh dang it, is equal to P plus R1. Angle P plus R1. The reason is exterior angle of a triangle. Ek is besig, man. I'm bees. Anyways, let's see. So here we have P, we have nothing. R1, we have it as a Y. So here we can say, therefore, remember y2 is x is y plus x, right? So we can put here y plus x equal to angle P. R1 we have already, remember R1 we labeled it as Y. See, we labeled it as Y. So here we can say the Y goes to the other side, Y minus Y plus X. Therefore, angle P is equal to X. So you see, as long as we have been able to show that this is equal to X and this is equal to X, it means that we have proven that we have a tangent over there. So here we can then say, therefore, SR is a tangent at R. Therefore, SR is a tangent at R. You see, this is not like the proof of the 10-chord theorem. It's just proving that a line is a tangent in our circle, because they have not told us it's a tangent in the description. So here they say we should prove that QR is a tangent to the circle passing through QXP. Where is QXP? QXP. We should prove that QR is a tangent passing through these points. Well, this one is easier. I don't even know why it's 3 marks. Because for this question, if we have this as the tangent, if this is going to be the tangent to a circle passing through PQX, this one is so much easier, because remember, we have shown that angle Q2 is equal to X, or rather Q2 is equal to this because of alternating angles. So as long as these are equal, then it means that these are also equal. But let's just tell them that. So here we can say here Q2 is equal to P3. Just tell them that. No, R3, bro. Yeah, this is R3. So this is equal to that because of alternating angles. Remember, in the previous question, that did not necessarily help us. So it's literally one of those situations where you write it out, but it really doesn't amount to anything. So you can actually just remove that. So here we have said those are equal because of alternating angles. Now we can tell them that R3 is equal to P. Proven. R3 is equal to P. That's proven. You see. So therefore, since they are both equal to R3, it means that Q2 is equal to P. So if Q2 is equal to P, then technically speaking, QR is a tangent to the circle passing through QXP. Therefore, here we can say, therefore, QR is a tangent to circle. Come on now, write better. Is a tangent to circle QXP. The reason for that is converse of 10-chord theorem. Converse of 10-chord theorem. Anyways, why did I write chord in such a weird way? 10-chord theorem. I meant chord. 10-chord theorem. Anyways, let's move on to question 11. Anyways, with this question, it says here, in the diagram below, OP is parallel to LM. Yes, we can definitely see that. They've also labeled it on the sketch there. And then they also said here, okay, so those lines are parallel such that the area of triangle KOP, the area of triangle KOP is equal to the area of quadrilateral OLMP. OLMP. What? Yo? Hey. Yeah, that just looks weird. And yeah, but I mean, they're telling us. So this triangle here, KOP, whatever the area of this triangle is, it is the area of the triangle OLMP. So this sketch is definitely not to scale at all. And then they said here, KYX, KYX is perpendicular to OP. So if it is perpendicular to OP, automatically it is going to be perpendicular to LM because those lines are parallel. This is parallel to this, so these have to be corresponding angles. So if this is perpendicular to that, I think you get the idea. So here it says it's perpendicular to OP and LM. Oh yeah, and then it says here, yeah, perpendicular at Y and at X respectively. So for 3 marks, they say we should prove that the triangle KOP is similar to KLM. So that's not going to be too bad. Or that doesn't look like it's going to be too difficult, because if you're going to prove that 2 triangles are similar, you have to show that the 3 sets of angles are equal. The first one is K. K is a common angle. So we can just say here K is equal to K, common angle. And then, I mean, these are both equal because they're corresponding angles. So O1 is equal to L, corresponding angles. And then lastly, P1 is equal to M, also corresponding angles. This one is one of those easy ones. And then you can then say, therefore, triangle KOP is similar to triangle KLM. The reason is just angle. Well, let's just write A. So I've shown the 3 angles are equal to each other. That's how those triangles are similar. So that's not too bad. For 2 marks here, they said we should prove that KY, where is KY? KY is this line here, KY over KX. KX is the long line there. So let's actually get an orange or something. So we should prove that KY over KX is equal to OP over LM. Is equal to OP over LM. Yee. Okay, that's kind of interesting because it just is, you know. It just is. It really just is. How many marks? It's a 2-mark question, so we would not want to overthink it, because why not? No, why overthink a question that's not to be overthought? So let's just look at the sketch a bit closer here. So no, let me just read this here. Looking at the sketch a bit, this is one of the last questions. Oh wow, we're almost done. Wow. KY over KX and then OP over LM. Oh goodness. Well, the one thing I'm thinking of is, okay, fine, can what we have just done help us? You know, because we know that in terms of similarity, we know that the question we have just worked out here, the thought would be, how can it help us to work out what it is that they're asking us here? Because the one thing is, fortunately, anytime that anytime that you get a question that is always going to ask you something like this, and you have just worked out similarity, or you have just proven that 2 triangles are similar, the one thing you obviously definitely want to do is to see if what you would have just worked out can help you in the question that you will be at. However, this is only a 2-mark question, so yeah, it almost feels like a bit of an overkill, but you don't shoot yourself in the foot by not making use of the previous question. So here, from the previous question, right, just because we know that these are similar, we can write out, you know, 3 expressions because of the proportionality theorem. So let's actually start there. You see, with these two being similar, what we can write out is that KO over KL, KO over KL is equal to OP over LM, OP over LM, which is also equal to KP over KM, like that. So the reason for writing all this will just be proportionality theorem. Let me maybe write it here. Prop theorem. You see. So with that being said, what we know is if you look at these 3 here, one that's useful to us is this one in the middle here. See, this one in the middle. So we can just keep that one in mind. So what we also know is that, I mean, like if you think of it logically, right? We have this ky here and we have this x. What is it? We have ky here and then we have kx. So if you look at it nicely, this triangle here up here, we have the k y o. The other triangle that we have is k x l. Excuse me. So with these two triangles, right, remember these lines here are parallel to each other. This line is parallel to this line. So what we already know is that as long as those lines are parallel, we know that our triangles are similar. You know, so as long as these lines are parallel, this is equal to that, this is equal to that, and that's a common angle. So without overthinking it, right, we know that based on these two triangles, we can write out an expression where, because remember, all we want here is something that has OP and LM. And I mean, like, unfortunately, it doesn't. I mean, if you're looking at it now, we can already see that the only way we're gonna get OP and LM, one more or the other, is if we use this KO and KL. This is from the previous question, right? We already know that KO over KL is equal to OP over LM. This we know because of the previous question. So what we're saying is in this sketch, or in these two sketches, there's a KO over there and there's KL over there. So based on these two images, right, we can write out that KO over KL is equal to KY over KX. You see? Because look, KO over KL is equal to KY over KX. The reason for writing this will be proportionality theorem. See? Let's put that down there where our question is. Copy, or let's just maybe cut it. Cut. Let's put that here. Paste. So you can see we have two statements that are both equal to KOL. See, this one is equal to KOL, this is equal to KOL. So we can say here, therefore, OP over LM is equal to KY over KX. That's why this question is just a 2-mark question, because we really don't have to overthink anything. So these we said it's similar because of the proportionality theorem, and we can just add here OP is parallel to LM. OP parallel to LM. And then we are good to go. Anyways, let us move on to this last question here out of 6. So with this next question, I've been looking at it for a while now, and hey, to be honest, it looks as though there's some piece of information missing here. because if we think of what is this? Let me remove this thing here. If you think of the question, right, with this information given, them asking us to show that KO over KL is equal to 1 over square root of 2. This is the only thing that makes sense so far. If you think of these two triangles, right, the KOP and KLM, those two triangles, right, let's write them here. Triangle KOP, which is the small one up here, and then KLM, and triangle KLM. The first thing is K is a common angle. So if you're to get the area of this triangle up here, right, you would use the formula. You can use the sign, the area rule, which will say a half multiplied by one side, which is KO, multiplied by the other side, which is KP, and then multiplied by sine the angle. Let's put this area as the numerator. Our denominator, let's make it the area of this triangle using the same idea. If you're going to say a half multiplied by one side, which is KL, multiplied by the other side, which is KM, multiplied by sine the angle. This is going to be your area of your two triangles, right, as a ratio. So one area over one area. So this would cancel this would cancel this. Now here you're left with KO over KL multiplied by this KP here, this KM at the bottom. Now if you look nicely, KP and KM, what we know is KP over KM is equal to KO over KL. So where you see this here, you can easily write it as KO over KL also. This is a meaning here you can easily have here KO over KL also. And then what that gives you is, technically speaking, KO over KL both squared. Now what this is telling us is the area of the one triangle over the area of the other triangle. We know that the ratio can be written as KO squared over KL squared. Now thinking of it nicely, right? If you want to write this as one fraction with one exponent, you'd have KO over KL squared. So this is what we're ending up with, right, in terms of having KO and KL. Now the only way KO or KL can be equal to this expression is if we had been given some kind of information that would allow us to say that the area of the small triangle up here and the area of the big triangle there, we would need to have been given some form of information that tells us that the ratio between these two triangles, the small one up here and the big one, is 1 to 2. As long as we don't have that information, or as long as we are not given anything that we can use to show that the area is 1 to 2, it makes this question almost weird. Like there's just something missing. You know, I know they told us that the area of the triangle here is equal to the area of the quadrilateral over there. But then if you're going to use the formula of a trapezium and the area of the triangle up here, yeah, it's still quite vague, because the only way you can go from KO over KL squared, the only way you can eventually have this is if KO over KL is equal to, is if this thing here is equal to a half. Meaning, remember, the area of one triangle over the area of the other triangle, there needs to be information telling us that the ratio is 1 to 2. You see, of which we don't have that information. You could think to yourself, okay, fine, what if you use another method to like write out the expressions for the areas? It won't necessarily work, because if you write half base times height and then half base times height, you still end up with, you know, KO squared and KL squared. But in whichever way, as long as this is an expression, you end up with We know that if you square root both sides, you square it here and you square it here, you can have KO over KL, and then square root of 1 is a 1, square root of 2, you know, it's just going to be square root of 2. So in my own opinion, maybe I'm not seeing anything right now, but one or the other, this question, yeah, it just looks a bit weird. There has to be something in the description to give us more information to say that the area of this small triangle up here is half the area of the, excuse me, of the big one over there. But there's nothing, you know, there's like absolutely nothing. We know that these are similar, fine, and they told us that this over this is equal to this over that, fine, but that's it, you know, KOP, KLM, yes, we know they are similar, and then this small one is similar to that one there. Yeah, this is just a strange looking question, but for now I'll leave this over here. For any more update on anything with regard to this question or any other questions, you can always check on IG on my math page, actually, at zero aesthetics. That's a E. Whoa. Aesthetics underscore just mathematics. Mathematics. Hey, come on. There you go. Yes, there's no E there. It's just ASTHE. You can always hit me up. Check on this page if I'll put an update for this question. But for now, that is that from my side. I will catch you in the next video. If this was helpful, don't forget to subscribe. Don't forget to plug your friends, because on this channel, yeah, it's basically me going through full past papers from start to finish. And then on the main channel, that's where I go through the tutorials bit by bit. Yeah, let me vamos.